All right, in this video, we are going to expand our conversation on exponents. We're going to talk about negative exponents. And a negative exponent is actually the result of repeated division. So we can think of negative exponents as kind of the opposite of positive exponents, whereas positive exponents talk about repeated multiplication. Negative exponents refer to repeated division. So let's kind of take a look at a pattern of numbers here and see if we can again use some reasoning here to make sense of negative exponents and what they're telling us. So what I have here are some positive powers of 10 and they are decreasing. And I want to continue this pattern just to see what happens as we decrease our powers of 10. 10 to the fourth power is 10,000, or a 1 with 4 zeros. 10 to the third power is 1,000, or a 1 with 3 zeros. 10 squared is 100, or a 1 with 2 zeros. 10 to the first power is just 10, or a 1 with 1 zero. So what would 10 to the 0 power be? Now, a lot of people would say that it's 0. 10 to the 0 power is 0. Well, is that actually going to be the case? Well, if we look at the pattern here, what's happening as we decrease our power of 10? We're actually dividing by 10 each time because we're decreasing the number of times we're multiplying by 10. There's one less factor of 10, so it's like we're dividing by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. So if this pattern were to continue, which it has to, I have one less factor of 10. So what's 10 divided by 10? Is it 0? No, it's 1. 10 to the 0 power is actually 1. And actually anything to the 0 power is 1. And we're going to see that here in a minute. Now, what if we continue this pattern into the negative exponents? What's 1 divided by 10? 1/10. What's 1/10 divided by 10? 1/100th. What's 1/100th divided by 10? 1/1000th. And what's 1/1000th divided by 10? 1/10,000th. So you can see that these numbers keep decreasing and decreasing and decreasing. They're not actually going to become negative. They're actually just going to keep getting smaller and smaller and smaller because we keep dividing by 10, repeated division, as we continue with these negative exponents. So what I really want us to notice is the connection here between the positive and the negative exponent. 10 to the first power is 10. 10 to the negative first power is 1/10. 10 to the second power is 100. 10 to the negative second power is 1/100. Do you see it? What's happening here? 10 to the third power is 1,000. 10 to the negative third power is 1/1,000. 10 to the fourth power is 10,000. 10 to the negative fourth power is 1/10,000. Do you remember the word that we have for these pairs of numbers? 10 and 1/10, 100 and 1/100th, 1,000 and 1,000th, and so on. These are called reciprocals, or multiplicative inverses. So here's the take-home point. Negative exponents are actually reciprocals of positive exponents. So if you know the positive, you can figure out the negative. You just find the reciprocal. So in these two boxes here, I have general statements that are always true. So in the green box, I have a to the negative n power. Well, that's going to be equal to 1/a to the n power. Okay, so we can actually evaluate negative exponents using the positive exponents. You just have to flip it over, find the reciprocal. And then likewise, a to the n power is equivalent to 1/a to the negative n power. So whenever you find the reciprocal of a power, the exponent becomes opposite. So I have some examples here below. 3 to the negative fourth power is the same as or equal to 1/3 to the positive fourth power. They are reciprocals, and which is 1/81. So 3 to the negative fourth power is 1/81st. 6 to the negative third power is equal to 1/6 to the third power, which is 1/216th. And then m to the negative 7th power could be rewritten as 1 over m to the positive 7th power. So you get that? These negative exponents are reciprocals of positive exponents. And then another thing we discovered was anything to the 0 power except 0 is 1. Okay, we saw that with 10 to the 0 power. We saw that's going to be 1. If we would have used any base there, we could have used 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd power, 2 to the 1st power, 2 to the 0 power. It would have been the same result. We would get 1 every time. So any number except 0 to the 0 power is going to be 1. It's not 0. It's actually 1. If you want more explanation for that, I can offer that. So feel free to ask me to show you why that has to be true, but I'm not going to do that in this video. So some examples: 14 to the 0 power, yep, it's 1. Negative 6 to the 0 power, yep, that's 1. And h to the 0 power, again, that's going to be 1. Anything to the 0 power is 1. So let's practice writing these expressions using a positive exponent. So I want to rewrite these negative powers with a positive exponent. And all I have to do is find the reciprocal. So the reciprocal would be 1 over 2 to the positive 3rd power. 2 to the negative 3rd power is the same as 1 over 2 to the 3rd power. M to the negative 4th power. What do you think this is going to be written with a positive exponent? 1 over m to the 4th power. 3 to the negative 5th power. What's this going to be written with a positive exponent? 1 over 3 to the 5th power. And then y to the negative 3rd power, 1 over y to the positive 3rd power. So if we want to write an expression or a power with a positive exponent, we simply just find the reciprocal. We flip it. Now we're going to do kind of the opposite. We're going to do it the other way. We're going to write each fraction as an expression using a negative exponent other than -1. We're not going to use -1 in any of these examples. So sometimes we don't want something written in fraction form. We want it written without fractions. So we're going to have to learn how to find the reciprocal here. So 1 over 4 to the 2nd power, if I'm writing that with a negative exponent, would be 4 to the negative 2nd power, just the reciprocal, just flip it. 1 over 6 to the 3rd power is equivalent to 6 to the negative 3rd power. 1 over 25, well, this one doesn't have an exponent on it. Well, it does, but it's a 1, 25 to the 1st power. But we can't use -1, so we have to rewrite 25 with an exponent, and the only way to do that would be 5 to the 2nd power. 1/25 is equal to 1 over 5 squared, and then if we want to write that with a negative exponent, it would be 5 to the negative 2nd power. Find the reciprocal. And then lastly, 1/27th, if I write this with an exponent other than 1, it would be 3 to the 3rd power, 1 over 3 to the 3rd power. And if I want to write that with a negative exponent, that would be 3 to the negative 3rd power. Again, it all has to do with the reciprocal, the multiplicative inverse. And then we're going to evaluate some expressions here. And again, be careful when substituting. When the variable is a negative number, we have to use those parentheses like we learned in the last video. 4 times -2 to the negative 5th power. Now this is a situation where middle schoolers will totally mess this up, but really you just have to keep it simple. Don't overthink this. Now the -2 is not going to become positive, okay? Only exponents will change their signs when we do the reciprocal. So if we're trying to evaluate this, I don't know how to evaluate to the negative 5th power, so I am going to find the reciprocal of just the -2, because that's the only thing the exponent is on. This exponent does not apply to the 4 at all, so I'm not going to find the reciprocal of the 4, keeping the 4 the same, but I'm going to find the reciprocal here, -2 to the positive 5th power. Notice that the exponent was the only thing that became positive, not the base. The base will not become positive when we find the reciprocal. Okay, and then if I evaluate -2 to the 5th power, that's -2 times -2 times -2 times -2 times -2, which is -32. So this is 4 times -1/32, which is -1/8. Evaluated. Let's take a look at a few more expressions here that we're going to evaluate. M to the negative second power, if M is 4, I have 4 to the negative second power, which is 1 over 4 squared, which is 1/16 evaluated. 6mn to the negative fourth power, that's 6 times 4 times 3 to the negative fourth power. I can do this. This is 24, and this is going to be 1 over 3 to the fourth power. And 3 to the fourth power is 81, I believe. 24 times 1 over 81, and that's 24 81sts, which in simplest form is 8 27ths evaluated. And then this last one, negative n to the negative third power, negative 3 to the negative third power. Now here I don't put parentheses around the negative and the 3 because the negative was out in front of the n. This exponent only applies to the n since there was no parentheses here around the negative and the n. It only applies to the n. So this negative is not going to get repeated or brought along when I find the reciprocal. 1 over 3 to the third power, negative 1 over 3 to the third power, which is negative 1/27th evaluated. Okay, so negative exponents, reciprocals of positive exponents. We just have to be careful and take care of the details, and we'll do just fine.